let's look at a word problem with a quadratic function. So we have a golf ball that is hit and its height h is in feet after t seconds. And it's given by this h of t, which is negative 16t squared plus 60t. So we're plugging in t, which is in seconds, and we're getting out h, which is in feet. Okay, determine the initial height of the golf ball. So initially would be times 0. We want to plug in h of 0. What's the initial height? Initial tells me to use t equals 0. So I'm going to do negative 16 times 0 squared plus 60 times 0, which will just get me 0. And this is the height, so it's feet. Initially, the ball is at 0 feet above the ground, aka it's on the ground. And if we want to compare that to determining the height of the golf ball after 2.5 seconds, so initially it's starting on the ground, now we've hit it. So we're going to look at 2.5 seconds later, how high up the ball is in feet. I'm doing negative 16, I have parentheses 2.5 squared plus 60 times 2.5. After 2.5 seconds, the ball is up 50 feet in the air. We're going to generate a table of some y values for this function to be able to sketch what it looks like. We've already plugged in a couple values. When you plug in 0, you get 0. When you plug in 2.5, you get 50. I'm going to grab my calculator and plug in the other values by replacing the t's in parentheses with a 0.5, gives me 26. If I plug in 1, I would have negative 16 plus 60, which would give me 44. 1.5 seconds in, the ball is still traveling up. It's gone from 0 feet to 26 feet to 54 feet, up to 56 feet after 2 seconds. Then 2.5, it's starting to come back down because we went from 56 to 50. Then at 3, we'll be at 36. At 3.5, we're at 14 feet in the air, and then we're down at negative 16 for 4. So putting this onto a chart, we're going to get the general shape of a quadratic. I need to choose some units to put onto the side here. I'm going to go ahead and do like halfway between these lines. And we want to go all the way from 0 to 56. So I want this top piece to be 60, and half would be 30, and these halves would have to be counting by 15s. Just to get a general sketch, this is going to be 1, 2, 3, 4 seconds in. So this down here would be negative 15. So we're at 0, 0 to start. Then we're at 0.5, 26. So we're in here between 15 and 30, a little bit closer to 30. At 1, we're at 44, so just under 45. At 2, we're at 50. Oh, I guess we can do 1.5 in here is 54. At 2, we're at 56. This is not going to be perfect, but we're just going to kind of go with our best guess here. At 2.5, we're down at 50. 3, we're at 36. And 3.5, we're at 14. And then at 4, we're down at negative 16. So our same quadratic shape, this has a negative coefficient, so flipped it upside down. But here's our shape of our quadratic. according to our table and graph about how long was the golf ball in the air. Does this make sense? So if we look at our table or our graph, looking at the table first, we start at 0 feet, we go up 26 feet, 44 feet, 56 feet, and then we start coming back down to 36 feet, 14, so at 3.5 seconds, we're still 14 feet in the air, and then at 4 seconds, we've dropped below. So somewhere between 3.5 and 4, it looks like we are back at 0 feet in the air for the ground. If we compare that to the same thing we just drew, the golf ball starts on the ground, it goes up in the air, reaches its max height, and it turns back around. And then somewhere between 3 and 4 seconds, it's back to a height of 0 here. So we could say some number between 3.5 and 4 seconds, maybe like 3.75 seconds. Does this make sense? I would say yes. Golf balls don't stay in the air for 5 minutes after you hit them. They also aren't up and down, ideally, on this drive within a second, but within 4 seconds, it's already back on the ground. Estimate the maximum height of the golf ball. So according to our chart, it looks like it's around 56 feet. Maybe if we plugged in, like 2.125, we could have gotten a little bit higher than that. But based upon our chart we have here, that's the highest number I see. It's a little bit lower at 1.5 and lower again at 2.5. So around 2 seconds and it gets at 56 feet. And then it says estimate when we've reached the maximum height, about 2 seconds in. Looks like that's the highest Y value we see either on the graph or on the chart. And what type of function is this? It's quadratic, which we could tell by that t squared being the highest power. So here is a graph of a quadratic function that comes up in real life. If you hit a golf ball, you start out on the ground, you reach a max height at some point, and then it hits the ground again, and so you get that parabolic shape.